We're going to take a look at some algebraic expressions, and most of this will be a refresher for some of you, and hopefully for some of you it sparks some memories. So we need to remember that the word variable means that things can change. For example, the weather is variable from day to day, but the word constant means to stay the same. That's very important when we take a look at the difference between two words in the definition of an expression, which is what we're going to be talking about a lot of today. So this first part is going to be a lot of definitions. A lot of this you will have heard before. So a term is a math statement, and it can be a single variable, a constant, a multiplication statement, or a division statement. So here's 4 examples of terms, and what we have here is x, and this x is a variable on its own. This is negative 18, and because there is no variable here, we call that a constant. These are both different types of terms, but they're all terms. Here we have a more complicated term that is made up of a multiplication statement, and that's okay. This is still just one single term. And what we have in front of looks like a constant, but it's actually not a constant. That is called a coefficient, something we should have heard of before. And the idea here is that it is multiplying everything in this term. There's also a coefficient in this last example. This is a division statement. And in this division statement, we see a variable. The variable is x. And we have a coefficient of 3/7. So for this particular one, our coefficient is a fraction. Now, an expression is something that is made up of terms. And so we've got these 4 examples of terms up here. Well, here's 3 examples of different expressions. An expression does not have an equal sign. That's very important. We're just expressing some math. So here again, we have a coefficient of 4 with a variable of x, a single term expression. Here we have something called, well, actually, you know what? When we only have a single expression or a single item or a single term, that's called a monomial. And when we have 2, we call that a binomial, just like a bicycle has 2 cycles, actually 2 wheels. So 3x squared plus 4x is 2 different terms. We've got 2 different coefficients, and we even have 2 different variables, if you will, because there is an x squared here, and this is an x to the power of 1. So these are what we call not like terms. We've talked about like terms in the past as well. And here we have 3 terms. We cannot simplify this. There are no like terms in here. We do have a constant. We have the constant of 2. We have a 6 as a coefficient on an x squared and a negative 7 on the coefficient of x. This is called a trinomial because there are 3 terms. So you might hear me or other teachers or people discussing monomials, binomials, trinomials. After that, we really just call them polynomials. All of these are polynomials, meaning many numbers or many terms. If the expression has an equal sign in it, well, we don't call it an expression anymore. We call that an equation. Let me just bring this down. Okay, so we have an equation. So an equation states that 2 expressions are equal. And so if you have 2 expressions here, I've got one on the left, 7x plus 2 equals all of this. That is actually an equation. And it's going to be important for you to tell the difference between an expression and an equation later on. Right now, what we have on the left-hand side is we have a binomial. And then on the right-hand side, we actually have a trinomial. We've got 3 different terms here. So this is a trinomial because we have a term right here, and it looks like it might be more than one term, but because we have a y on the outside of the bracket being multiplied here, technically right now, as it's written, it's a single term. We could expand this in, and we're going to talk about that in just a little bit, but then we also have a term here, a positive 6x, and then we have a term here, a negative 5, and so this is a trinomial. Now, all of those different terms, they are usually separated by pluses, minuses, or equal signs. That's very typical. Sometimes you will see them separated by a division sign, but not too often, especially in the work that we're going to be doing. Okay, so just another reminder, or in terms of some terminology, a factor. A factor is a multiplier in a term. So we have this coefficient of 4 on front of this x. So if we were to take a look at the factors of 4x, we might say that one of the factors is 4 and another factor is x. But in fact, there are other factors. For example, 1. 1 is a factor because I can say that 4x can be written as 4x times 1. I can also say that 2 is a factor because the number 4 can be written as 2 times 2. And so my factors could be 1, 2, 4, 4x even, x. I've got a lot of different ways that I can say the factors of this particular term. And if we take a look at an even more complicated example here on the right-hand side, we've got definitely a term of 9. We've definitely got a term of y minus 2 squared. Now, y minus 2 squared on its own can be written as y minus 2, so that's another factor. And if we really wanted to dive right in, we could say that 9, well, 9 is actually made up of the factors 1, 3, and 3. So we've got a lot of different factors here that can be part of this particular term. We're going to be talking about factoring a little bit later too, in terms of figuring out different pieces of an algebraic expression. Okay, so let's talk about like terms for a second, something that I didn't originally have in my file here. So a like term, the idea here is if they have the same variable, and I'm going to put variables because they can have more than one, and the same degree. And the idea of the same degree is this idea of what is the value of the exponents on the variable. So I'll just give a couple simple examples here. If I have 3x, 4x squared, and 7xy, none of these are like terms because the 3x has an exponent of 1, the 4x squared has a power of 2 or a degree of 2, and the 7x has a y on it, so this is not a like term. If we were to take a look at another example, if I had something like 4x squared y and 6x squared y and 8, or maybe even negative 8x y, there are only two like terms here. The two like terms are these two here, the 4x squared y and the 6x squared y. The reason why the negative 8xy is not like, it's not because of the negative sign, it's because of the power, or at least the lack of the exponent on the x. And so if we ask you to collect like terms, it's really just this idea of adding and subtracting like terms. So if I have 3x and 4x and 5x, and I ask you to, collect those like terms, you're going to count how many x's there are. Well, there's 3 here, there's 4 here, and there's 5 here, so that's 12. There are 12 x's. Notice how I didn't change what it is. It's still just an x. It doesn't become x squared or any sort of fanciness like that. We get into things like making them x squareds when we multiply. So if I had a 3x times a 4x, that's when we would change what the x is, because the 3 multiplies times the 4 to make 12, and the x multiplies times the x to make x squared. And so that's when we get the changing of the power. A lot of this is review from grade 9. Okay, so let's talk about the distributive property. Now, the distributive property is known as different things. A lot of teachers just call it expanding. Many teachers will call it distribution. And the idea here is that we are going to be multiplying multiple values. We're going to be multiplying multiple values by the same coefficient. So I want you to think about having like a package. So if you had a pencil case, and in that pencil case you had 2 erasers, a pencil, a calculator, maybe a pen. And somebody says, oh, I really like that pencil case. Can you sell me that pencil case, or maybe even make more of them? And some more people get involved and they say, well, we want 4 of those same pencil cases. You're going to need to have the proper number of erasers, pencils, pens, calculators. And so right here I've got this package. We can think of the brackets as a package. So I've got this package, and in that package is of x minus 7, and I want 4 of them. And so what we're going to do is we're going to discover how many of each thing do we need. Well, if we're going to expand this, the idea here, we are going to distribute or pass on the coefficient of 4 to these 2 items. And so we could rewrite this as 4 times x, as well as a 4 times a negative 7. And the pluses and the minuses can get a little confusing here, but the 4 is positive, and so we're multiplying a positive 4 times a negative 7, and this creates a new expression. And so that creates the expression 4x, and a 4 times a negative 7 is negative 28, so it's 4x minus 28. Now some other people, they don't tend to write it like this. What they'll do is they'll take that expansion, and instead of writing it out in its separate pieces like this, they'll actually just write out 4x minus 28, having multiplied 4 times x and 4 times negative 7. This intermediate step is helpful for some people, but other people, they leave it alone. We have a slightly more complicated one here to finish off this video. We're asked to rewrite this expression in expanded form. Taking a look at this expression, we've got a monomial. So we've got a monomial times a trinomial. And then on the end, what is this? What is that? Well, there's just an extra term. That's a monomial again. And that is not part of the multiplication. So let's take a look now at expanding this. I'm going to multiply the x times this first term. And when I multiply that x times that first term, I get 3x to the power of what? The 3 is just a 3 because there's a 1 on this x, so 1 times 3 is 3, and x times an x to the power of 3 is x to the power of 4. And if you wanted to write the intermediate step, you could easily write the intermediate step. That's up to you. I'm going to multiply the x times the 7x, and 1 times 7 is just 7, and x times x is x squared. I'm going to now multiply the x times a negative 6, and the x just gets tacked on as the variable. The negative 6 is no longer a constant, is now a coefficient. Now I still have this little friend here, my friend of 9x, if you will, so he's going to tack on to the end. And now we need to collect our like terms to finish the simplification. I only have a single term with an x to the power of 4. I only have a single term with an x squared, but I have two terms with a power of x to the power of 1, rather, a degree of 1. And I've got a negative 6 of them and a 9 of them. And this goes back to our integer work and our ability to add and subtract integer values. The x does not change its degree. We're just collecting the fact that we had 6 negatives, 9 positives, and they collect together to make a positive 3. Then we finish off with this trinomial. All right, there's plenty of other videos online that express this. Khan Academy is filled with them. And if you have any questions, do not hesitate to contact me.